Okay, so we have this quadratic function over here, and from this we have to obtain all of these things. I will start by getting the vertex using the axis of symmetry, which is this formula right here, and we will be substituting. So that will give us negative, and we substitute negative 3/4 over 2 times 1/4. So negative times negative will give us 3/4 divided by, and then 2 times 1/4 equals 2/4, which I will simplify into 1/2. 3 times 2 equals 6, and 4 times 1 equals 4. And then we can simplify that into 3/2. So we have the first value of the vertex, which is 3/2. Now, since it is the x-axis of the vertex, we will now substitute it in here. So 1/4 times, and then 3/2 to the square, since we are substituting it here, is 9/4. So I will be skipping that step. Minus 3/4 times 3/2 plus 1/2. Okay, now we simply multiply this. 9 over 16 minus 9 over 8 plus 1/2. And then we have to find the least common denominator, which is 16. 16 minus 16. So we pass this. Then 8 to be 16, you have to multiply times 2 times 9. And then 16 divided by 2 is 8. And now this will give us minus 9 over 16 plus 8 over 16. Okay, which is minus 1 over 16. And that is the second value of the vertex. Now, for the concave, since the leading coefficient 1/4 is bigger than 0, then it will be concave up, like this, and it will have a minimum point. So this is concave up, and it has a minimum. Now for the y-intercept, it is simply the independent term, which is 1/2. And the roots, we will multiply the whole equation times 4 to get rid of the denominators, and that will leave us with x squared minus 3x plus 2. Now we need to find two numbers that will give us multiplied positive 2 and subtracted negative 3. And those numbers are minus 1 and minus 2, which when passed to the other side give us positive 1 and positive 2. Those are the two roots. So now we have everything here. The vertex is 3/2 minus 1/16 and everything else. Now we must graph it over here. So I've already put the points in x equals 2, x equals 1, then the vertex right here and the y-intercept. And then you just have to do an approximation of the parabola where it touches all the points, and it will be something like that. That's it.